Why you always in the mood? Fuck around like I'm brand new. I ain't tryna tell you what to do, but try to play it cool. Baby, I ain't playing by your rules. Everything look better with a view. Why you always in the mood?
Hi, welcome back to Undetermined coefficient method. So now in this video, we are going to discuss about case 1 by using undetermined coefficient method. So what is case 1? Case 1 is when your fx is a polynomial function. Okay, polynomial function with degree n, where n is greater or equals to 0. So now let's take a look at the method of solution. In the notes, kita ada provide the method of solution. First of all, we need to find out what is your YH. Okay, since the solution is Y equals to YH plus YP, and Y homogeneous YH is obtained from your homogeneous solution by equating your fx equals to 0. This is what we have discussed last week. So for this video, we are going to discuss on how to get the YP. Then we combine the results of YP or the solution of YH and YP. Then only we get the solution of the non-homogeneous second order linear differential equation with constant coefficient. So now, for the method of solution number 3 and number 4. Okay, for number 3, it is stated that let R equals to 0, compare the each term in YP with the each term in YH. What does it mean? It means that here R comes from here. Okay, x to the R, and then you have the solution or the initial guess of your solution right here. Okay, and then we have R from 0, 1 and 2. Okay, the step of solution here I will discuss through examples. Okay, so let's take a look at the case 1, example 2.5. Solve the following differential equation by using the method of undetermined coefficients. Alright, so we are given y double prime plus 2y prime plus 2y equals to 5x plus 1. And then we try to ignore this one first and just focus on the general solution first. Alright, so we have y double prime plus 2y prime plus 2y equals to 5x plus 1. Okay, we know that by using the undetermined coefficient method, this method is just valid to solve for non-homogeneous equation with constant coefficient. Okay, so now you have this equation in the form of ay double prime plus by prime plus cy equals to fx. Okay, your fx is non-zero, so that you don't have any x square or x inside your equation. So this is the equation with constant coefficient, so that we can continue to solve this kind of question by using the undetermined coefficient method. By looking at or considering your fx here, which is 5x plus 1, this is a polynomial of degree n where n equals to 1, right? So the precondition in order to apply the undetermined coefficient method is fulfilled, so that we can proceed. Knowing that the solution is y equals to YH plus YP, so we start our calculation by finding what is our YH. In order to get YH, we must always equate our fx equals to 0. So by equating our fx equals to 0, our equation becomes y double prime plus 2y prime plus 2y equals to 0. Okay, so we have m squared plus 2m plus 2 equals to 0. This is what we have discussed previously, okay, on homogeneous equation. So we have b squared minus 4ac, where our b squared is 4 minus 4ac, which is less than 0. Okay, when we have this one, negative b plus minus square root of b squared minus 4ac over 2a. Okay, so we have negative b is negative 2. Okay, negative 2 plus minus of 4 minus 4, 1, 2. Okay, b squared minus 4ac over 2a. Our a is 1. so that we have negative 2 over 2, so that we have negative 1 plus minus square root of 4 minus 8, which is negative 4. So this one is square root. This one is equivalent to 4 times negative 1. So this one, square root of 4 is 2, and then square root of negative 1 is I. So that actually we have m equals to negative 1 plus minus 2i. And then we know that our m is alpha plus minus beta I. So now we can conclude our YH. Okay, so it falls into the b square minus 4ac less than 0. We have complex roots, so we get the solution of exponent negative x a cos 2x plus b sine 2x. So this is our YH. Then only we go to the solution of YP, because our solution is Y equals to YH plus YP. So now we want to find YP. Again, okay, in order to get YP, you must always consider what is your fx. Okay, since our fx, okay, our fx is a polynomial of degree 1. So what is the question? So we have 5x plus 1. So 5x plus 1. So we need to do the initial guess, which is YP. YP equals to x to the r, and then this one is a polynomial of degree 1. We start with polynomial of degree 1, then it will reduce by 1, so we have d. So we stop, and then r from 0, 1 and 2. So now we want to look what is the function of r, okay, when r equals to 0. Okay, so we have YP x to the 0, okay, x to the 0 is 1, so that we have cx plus d only. Then the method, the step of solution, okay, the method of solution, after you do the assumption or initial guess of your solution, we start with r equals to 0, substitute here, and then we say that I think this is my initial guess of my solution of YP. So betul ke tidak? Okay, in order to know whether you have the right solution or not, you stop for a while after you do the assumption, and then you check whether this solution exists in your YH. Ada tak YP, apa-apa term in your YP which is correspond to your YH? Ada tak yang sama? For example, look, do you have CX in your solution here? No, in our solution YH, we have exponent and cosine and exponent and sine. So, CX is not similar to your YH. Is it D similar to any term in your previous solution of homogeneous? No, tak ada apa-apa constant pun kan? Constant saja. This one is constant saja. Only just constant inside your YH or previous solution. Tak ada kan? So, tak ada. When there is no term which is similar in YP and YH, therefore we can conclude that this is our correct initial guess. This is our correct initial guess. Then we proceed. Okay, bear in mind that we must always compare solution to solution, solution to solution, not solution to fx. Okay, solution to solution means that YP compared to your YH, ada tak yang sama? Kalau ada yang sama, we cannot say that this is our correct solution. Then we proceed to R equals to 1. Okay, compare lagi, ada tak yang sama dalam YH? If ada, then we need to cancel it, and then we proceed to R equals to 2. R1 dengan R2 ni nak masuk kat mana? Masuk dekat sini, R x to the R. So that if let's say you have R equals to 1, so that your solution here, your YP becomes CX square plus DX. Okay, so since we have no term in YP which is similar to our YH here, then we can say that, okay, I want to say that this is my correct initial guess. When you say that this is your correct initial guess, then you find the first derivative and first derivative and second derivative of your YP. Okay, kenapa? Kita kata ini solution, tapi betul ke tidak? Betul ke tidak? Then you need to prove it. Okay, dan kita akan masukkan dalam actual solution, actual question nanti. Okay, kalau kiri dengan kanan sama means that betul lah, this is your correct initial guess. Okay, so now we find the first derivative, then we have C, then the second derivative is 0. After you find the first and second derivative as well as your initial guess of your YP, then we substitute into our actual question. So that is why nama dia YP, why particular, because dia mengkhususkan kepada semua equation kita lah, equation yang betul. Okay, instead of homogeneous tadi dia menggunakan fx equals to 0. So now the question is y double prime plus 2y prime plus 2y equals to 5x plus 1. Okay, so we just substitute y double prime is 0 here, plus 2y prime. What is y prime? Is c. Okay, c plus 2y. 2y is 2 times cx plus d equals to 5x plus 1. Okay, so now I want to expand this one, so I have 2c plus 2cx plus 2d equals to 5x plus 1. So I want to collect the same term untuk term x to the power of 1. X to the power of 1, I have 2c. On my left, I have 2c. Dah tak ada dah kan? Tak ada, yang ni bukan, yang ni bukan. And then my right hand side, I have 5x. So the term of x, so that I have the coefficient equals to 5. So I can conclude that c equals to 5 over 2. Okay. So, lepas saya ada x to the power of 1, of course dia akan reduce by 1. So x to the power of 0. X to the power of 0, saya boleh katakan dia adalah constant only. Okay, just a constant. So that I have apa? So that I have 2c on my left and then I have plus 2d on my left, while my right hand side is 1. Okay, I know that c is 5 over 2 plus 2d equals to 1. So that 2d equals to this one. So you have 5. 1 minus 5 is negative 4. Therefore, d equals to negative 2. Since I get the value of c and d, then I substitute back into my initial guess. My initial guess is yp equals to cx plus d. My c just now is 5 over 2. 5 over 2, substitute here, okay, cx. So I have 5 over 2x plus d. Okay, what is our d just now? Our d is negative 2. So minus 2. So this is our yp. Okay. So, go back to our solution. We can conclude that our solution is y equals to yh plus yp. What is yh? Exponent negative x, a cos 2x plus b sin 2x, then plus yp plus 5 over 2x minus 2. Okay, when we look at our solution here, we find that tak ada pun term yang sama. Sini ada 5 over 2x, okay, degree of 1. This one is degree of 0. This one you have exponent and cosine, and then exponent and sine. So tak ada apa pun satu term yang sama. So that we say this one is our solution. How to, this one is general solution lah. How to prove that you have this one is your correct solution? So apa yang awak boleh buat, you can try to differentiate twice your y, find y and y double prime dapat apa. Okay, and then you try to eliminate your a and b. Cuba eliminate a and b. So bila awak ada dekat sini kan y prime and y double prime, okay, cubalah eliminate the constant a and b, then awak akan dapat satu equation yang terakhir yang melibatkan y double prime plus apa-apa, and then your solution here should be your question lah. Mesti dapat balik soalan lah. Kalau tak dapat balik soalan means that something wrong somewhere with your calculation over here. Okay, so macam ni cara nak buktikan. You try to differentiate twice and then jadikan this one equation 1 ke equation 2 ke kan, and then try to eliminate your a and b. Tak ada dah a and b, and then you will have the y double prime as your question lah, question balik. Okay, but now the question asks you to find out the particular solution. So particular solution dia bagi y equals to 1 when x 0, y prime equals to 2 when x 0. So go back to our y here. This is our y kan, so salin balik lah. Y equals to exponent negative x, okay, a cos 2x plus b sin 2x plus 5 over 2x minus 2. So masukkanlah dekat sini y sama dengan berapa tadi? Saya pun dah lupa. So we try to get the initial guess. Okay, y equals to 1 when x 0. Okay, so masukkanlah dekat sini y sama dengan 1 apabila x 0. So masukkan, so this one becomes your equation 1. And then y prime equals to 2 when x 0. So awak kena differentiate your solution here, then only you can substitute the condition ini. Y prime sama dengan 2 apabila x kosong, and then you try to find out what is the value of a, and then what is the value of b. Dah dapat nilai a and b, and then substitute into your general solution, then only you get the particular solution. I hope that you can continue, okay, to find out what is the value of a and b, and then cross check with your friends. Okay, I really hope that you understand this one, okay, and please be careful that here you have exponent and then you times with cosine, so that in order to do the first derivative or differentiate this one means that you need to apply the product rule as well as this one. Okay, masukkan dalam ni. Okay, so that both of these you need to do the partial derivative lah, sorry, product rule. But this one is just direct differentiation. Okay, so that is the end of our discussion for example 1. So let's try to look at the example 2 after this, okay, in the next video.